In this session, we're going to discuss the difference between distance and displacement. Now, distance is very straightforward. Distance is just the total length traveled. Okay, so it's going to include every stop, every turn, every curve, and the total amount traveled. It can be measured in things like kilometers, meters, miles. Displacement, on the other hand, is not the total length traveled, but instead it's basically the shortest distance between 2 points. You're essentially taking the end point and subtracting where you begin. And the difference is going to be your displacement. Displacement does have a formula, and it has a couple of formulas actually that you'll use, but displacement basically is going to be given to you by delta x, which is xf minus xi. Now, what the heck does that mean? If you see a triangle, that stands for delta, and in science that means change in. So the change in displacement stands for xf, which is basically your final position, minus your initial position. Sometimes you will see it written as xe for end position instead of final, but in this case we're going to use f for final and I for initial. So it's final minus initial for displacement or any kind of change in problem or delta problem. In this example, you've got a tuba player walks 4 yards east, then 10 yards north, and then 5 yards south. What is his distance and displacement? Now remember, distance is the total length traveled, and displacement is the straight line distance between a beginning and an ending point. So what you're going to have to do, or at least what I'm going to do, is I'm going to draw a picture. So I'll start at point A, or just at the point, and I'm going to go 4 yards east. And I'm just going to use my little arrow to show my direction. And then 10 yards north, and it's not to scale by any means. And then another 5 yards south. So my ending point is here, and my beginning point is there. What makes it easier for me is if I use my initial I and my F there. Now, when I'm dealing with distance, it's total length traveled. So, basically, we went 4 yards plus 10 yards plus 5 yards. So, my distance traveled is going to be 19 yards. Whereas my displacement, that's a little bit different. With displacement, you're going to have to find this distance right here. You're going to have to find your hypotenuse, which means that you're going to have to attach some numbers to the sides of that triangle. Now we know that the bottom side of the triangle is 4 yards, but the right side, or the y component of that triangle, is not 10 yards. They went 10 yards north and they came back down 5 yards, so that means that the right component of the y component is now going to be 5 yards. So if I go ahead and rewrite my triangle in a little easier form to see, I've gone 4 yards to the right or east and a total of 5 yards north as far as displacement goes. But I'm looking for the total distance traveled, the shortest distance between 2 points. So when I'm looking at a triangle like that, I can use Pythagorean theorem to find for x, or for c. I would call this, I guess, c. And so I'm going to have c squared equals a squared, which I'm going to make 4 my a, plus my b would be 5 squared. So I've got 16 plus 25, and if my math is correct, I'm going to say that that is 41. So then I want my c by itself, so I'm going to take the square root of both sides, and the square root of 41 is going to be 6.40. So that's going to be my displacement traveled. So that's going to be 6.40 yards. Now, it's important to understand that for displacement, it has to have a number and a direction. So it's going to be 6.4 yards, and the direction is northeast. So that would be your general displacement.